Hello student, in this unit we discuss various kinds of the modulator, right? So this modulator normally used to design the optical switching. The optical switching, where you can use the optical switching in optical integrated circuit, you can use the optical switching concept. The concept is called the optical switching, and with the help of that device, you can implement the optical switching. Those devices are known as the logic devices. So, what is the concept of the optical switching? So, in photonic integrated circuit, sometimes we need to whatever optical signal is coming from the other side of the circuit, sometimes those signals we need to split those signal, and sometimes we need to remove the signal in there. We have to do such a way that the signal should not be come from one device to another device, right? In the right hand side you can see there is a device that is called the material, the nonlinear optical material. So this device is considered as a logic device, and the switching concept is that so there is a one name is the switching beam. Okay, so this is the input signal, and along with the input signal, we are getting a one extra signal. This signal is known as the switching beam. Okay, so the material has some property. So when you incorporate this switching beam, so what will happen? So due to some phenomena, the whatever input signal is there, the input signal will deflect and it will go in the other circuit. Suppose there are the multiple circuits. Okay, based on the phenomena, it will fade into the one circuit, deflected, and it will fade into one circuit. Sometimes we need to alter or we need to modify the switching beam such way that it will change the phenomena of the material in a different way, so that with the interaction of the switching beam and the input signal, the no output will come from the device. Okay, so this is the concept. Sometimes we need to pass the signal, sometimes we don't pass the signal, sometimes we will deflect the signal in a different circuit. So this is the concept of the optical switching. And various way you can implement the optical switching. One is the mechanical, and another is some other effect. Mechanical concept is that means, so suppose we have some optical fibers. So so suppose so many optical fibers are there, so we are removing the optical fiber manually, or we are changing uh, the types of the optical fiber, so that the signal will not come, whatever signal is coming, those signals will not come, or the signal strength will increase. Like this is the mechanical, this is the total manual concept. Other concepts are the electro-optic effect and the magneto-optic effect. So, whatever optical signal is passing through the optical fiber, based on our applications and based on our requirement, we have to apply the electric field such a way that it will alter the optical signal. This is the electro-optic effect. Magneto-optic means we are giving the magnetic signal, magnetic signal or magnetomotive force, something we are applying to the device, so that the optical signal will alter. So this electro-optic effect, magneto-optic effect, such kind of the effect we have already discussed in the previous lectures, right? So those effects effects will implement in a circuit for implementing the optical switching or optical logic devices. The optical switches, based on the speed also, you can divide the optical switches in two different ways. One is the slow optical switches and the fast optical switches. So slow optical switches like that manual thing. The optical fiber, we are moving the optical fiber, we are changing the route of the total photonic integrated circuit. So optical fiber, suppose this will place the optical fiber for one photonic integrated circuit. So sometime we'll changing the position of the optical fiber, so that the light will not enter through this optical circuit, it will go into the other optical circuit, photonic circuit. So this is the rerouting or the alteration of the routing concept. So this is the slow process. The next is the fast optical switches. This is the electro-optic effect and the magneto-optic effect. These are related to, if we implement the concept of the electro-optic effect and the magneto-optic effect, so those circuits are denoted as, or those switches are considered as a fast optical switch. So mechanical switch, if we see, this is the one device. The some lots of optical fibers are connected. You can remove the optical fiber, or you can, in place of the one specific optical fiber, you can uh, put another kind of the optical fiber, and you can shift the optical fiber in the various way. You can do it. The mechanical concept or mechanical switch. And electro-optic switch, this I told, this the one laser we are putting or applying some electric field, or the light should come from the laser. So due to the application of the electric field, light will not come from the laser, or the intensity of the light will also change. So these are the electro-optic switches. And magneto-optic switch, this to the magneto-optic switch, we are applying some electromagnetic force. Due to the electromagnetic force, data will how you are applying the electromagnetic force, based on that the data will be transferred from one location to another location. Thermo-optic switch is also like that. We are applying some thermal signal. Due to the thermal effect, the optical signal is diverted, or optical signal is passed through the devices. So normally for thermo-optical effect, we are going to use the silica and the polymer. The acousto-optic switch is the acousto-optic effect we have already discussed. This is related to magneto-optic concept. We're applying the acoustic wave into the device, which will change the reflective index. The concept is already I have discussed, which will change the reflective index. Due to the change in the reflective index, whatever input signal is entering into input optical signal is entering into the device. Due to the acoustic optic effect, the input beam will deflected, or input beam will not come from the not from the device, right? So if we remove the acoustic effect, then the light will be the signal will be passed through the device. So the acoustic optic effect is also used for implementing the switch. Now next, the so the optical switches concept we have already. So in various way you can implement the optical switching concept, right? So and a logic device. Logic device means the device which you are using. So the device is known as a logic device. Normally, in case of the electronic concept or photonic concept, we normally used to convert the everything in a digital inform, right? So in electrical concept also, we are normally making nowadays we are using the digital circuit, digital integrated circuit, everything. Rather sending the analog information, we used to send the logical information, or logical analog digital information, right? So logic gates are used to pass the informations like either 0 and 1. Those signal will be passed. Okay, so for getting the analog signal also, those analog signal will be converted into the digital signal. So there are the various devices like the transistor and the diodes. Those are used for the logic gates in case of the semiconductor chip or electronic chip, right? So we'll implement the transistor concept such a way that if whatever input signal is coming, it will give either the one output, or it will give the zero output, right? That is the semiconductor industry concept. Now if come to the optical concept, right? So in the semiconductor industry, there are the two value we can put, and what are the materials we are using. The transistor and diode used to prefer for implementing the digital for case of the semiconductor industry, if want to implement the logic devices. But now come to the optics. So the for case of the optics also, you can design you can implement the switching concept, or you can design the logic devices in various. So one is using the photonic crystal, so you can design the optical logic device, and you can use some different concept like threshold logic. Suppose to be various beam splitter we can use, and ring resonator we can use to implement the logic device. And apart from that also, we can use the optical cavity. What is the concept of this thing? The optical cavity there. So both side of the device will be some face. There are two faces will be there, and the cavity that will support only certain wavelength, depending on its optical cavity length, and depending on the reflective index of the cavity. If reflective index of the cavity will change, so then it will not support some wavelength. It will, if it's constant, it will support the different kinds of the wavelength. Based on that, we can, with the help of the optical cavity, we can implement the logic devices. Normally, what we used to do here, so in the first slide I discussed that we can use a switching beam for implementing the switching applications, right? So in case of the optical cavity, normally the laser pulse is going to be used to change the reflecting index of the optical cavity. If the reflecting index of the optical cavity change, it will support some wavelength. Based on that, whatever input signal is entering into the device, so if not support the wavelength of the input signal, it will give the zero output. If the optical cavity supports the wavelength of the signal, it will provide the some output. So to the here in this diagram, I can tell, suppose this is the cavity. So two closed spaces device, and the one small opening will be there through which the laser input signal will enter into the cavity. Now you can see here we are not getting any output, here we are getting the output. Can see here in this case, in the first diagram, we are not giving any switching beam or laser pulse, and the second diagram we are providing the switching beam. Okay. Now, what is happening? The reflecting index of the media. So, the cavity is designed such a way that sometimes if the reflecting index of the cavity will change, it will affect the wavelength of the input signal. If the reflecting index of cavity will not change, it will not affect any wavelength of the input signal, right? So laser beam is entering, okay, right? And then here we are not providing the any laser pulse. So whatever reflecting index is there for cavity, same reflecting index will be remain same. So the input signal has some wavelength, okay. So this wavelength will not be supported by the cavity. If it is not supported by the cavity, so it will not maintain, it will not satisfy the resonance condition of the cavity, then no output signal will get from the cavity. Now here in the second case, they were giving one laser pulse which will be acted as the switching beam. So this laser pulse will change the reflecting index of the cavity. Okay, reflecting index of the cavity. If the reflecting index of the cavity will change. If reflecting index of the cavity change, then wavelength of the laser beam will change. Whatever laser beam is entering. So there, this concept is we have already discussed. If the reflecting index of the material will change, so if light beam is entering into the device, it has some wavelength due to the reflecting index. The wavelength of the everything, the wavelength of the properties of the light will change mainly. Okay, the wavelength of the light will change, which will support the whatever wavelength, the new wavelength we will get, that will satisfy the resonance condition of the cavity, and then that means the wavelength will be supported by the cavity, and due to that the same lines which has the sub wavelength, which is some wavelength which is satisfied by the resonance cavity, this wavelength will pass through the cavity, and will get some output from the cavity. Okay. So in this way we can implement the optical switch with the help of the optical cavity. So there is a condition for maintaining the resonance condition. Resonance condition of the cavity is the cavity wavelength is equal to 2n lambda by m. Okay. M is the multiples, n is the modes, and L is the length of the cavity. Okay. So and in different way, in various way we can design the optical switches. This I will discuss in the upcoming lecture. Please like, share and subscribe my channel.